Underground feeder cable, often referred to as UF cable, requires careful stripping to expose the conductors for electrical connections. Several tools and techniques can be employed, each with its own advantages and considerations. Firstly, a razor blade or utility knife can be used. Begin by marking the desired stripping length with a shallow cut. Hold the blade perpendicular to the cable and gently score the outer jacket. Avoid cutting too deeply to prevent damage to the underlying wires. Then, bend the cable slightly at the scored mark to snap the jacket open, exposing the wires. Secondly, wire strippers, specifically those designed for UF cable, offer a more controlled stripping process. Choose wire strippers that have notches or settings appropriate for the gauge of the UF cable being used. Insert the cable into the correct notch and squeeze the handles. The blade should cut through the outer jacket and separate the wires without nicking or damaging the insulation. Thirdly, scissors can be utilized to strip UF cable, although this method requires more caution and precision. Cut the outer jacket along the marked length, taking care not to cut into the wires. A sharp pair of scissors is essential for a clean and controlled cut. This method is best suited for smaller gauge UF cable where the jacket is relatively thin. Fourthly, specialized stripping tools designed specifically for UF cable are available from some manufacturers. These tools typically feature a built-in blade or a mechanism that makes a precise cut in the outer jacket at a predetermined depth. Follow the manufacturer's instructions for proper usage. These tools can save time and effort, especially when stripping large quantities of UF cable. Fifthly, heat stripping can be employed to soften the outer jacket, making it easier to remove. Use a heat gun or lighter to gently heat the outer jacket along the marked stripping length. Be careful not to overheat the wires or melt the insulation. While the jacket is still warm and pliable, carefully pull on it to remove it from the conductors. This method is particularly useful for removing tough or brittle UF cable jackets. Regardless of the chosen method, safety precautions are essential when stripping UF cable. Always wear safety glasses to protect your eyes from debris and gloves to prevent cuts or abrasions. Before stripping any wires, ensure that the power is turned off at the circuit breaker or disconnect switch. Mark the desired stripping length clearly on the cable to avoid cutting too much or too little of the jacket. It is also advisable to practice on a spare piece of UF cable before stripping live wires. This allows you to familiarize yourself with the chosen tool or technique and to fine-tune your approach. If the outer jacket is particularly tough, consider making several shallow cuts along the marked length before bending the cable to snap it. This will weaken the jacket and make it easier to remove. Ensure that the wire strippers are sharp and properly calibrated. Dull or misaligned wire strippers can damage the wires or make it difficult to remove the jacket cleanly. After stripping the UF cable, use a wire brush or sandpaper to clean the exposed copper wires before making connections. This will remove any oxidation or corrosion and ensure a good electrical contact. When selecting wire strippers, consider those with adjustable settings to accommodate different wire gauges. Some wire strippers also include features such as wire cutters, loop-in holes, and bolt cutters, making them versatile tools for a variety of electrical tasks. When using a utility knife or razor blade, be extremely careful to avoid cutting yourself. Always use a sharp blade and maintain a firm grip on the tool. Cut away from your body and keep your fingers clear of the blade's path. If you are unsure about any aspect of stripping UF cable, consult with a qualified electrician. They can provide guidance on the proper tools and techniques for your specific application. Additionally, it is important to consult local electrical codes and regulations to ensure that all wiring practices comply with safety standards. Proper grounding and bonding are crucial for electrical safety. Ensure that the grounding conductor in the UF cable is properly connected to the grounding system. Similarly, bond any metal enclosures or equipment to the grounding system to minimize the risk of electric shock. When running UF cable underground, bury it at the proper depth according to local codes. This will protect the cable from physical damage and prevent accidental contact. Use appropriate conduit or sleeves where the cable passes through walls or other structures. Secure the UF cable properly to prevent it from sagging or becoming damaged. Use cable staples or clamps that are designed for UF cable. Avoid over-tightening the staples or clamps, as this can damage the cable jacket. When making electrical connections, use properly sized wire connectors and terminals. Ensure that the connections are tight and secure to prevent overheating or arcing. Apply antioxidant compound to the connections to prevent corrosion. Label all circuits clearly and accurately. This will help to prevent confusion and ensure that the correct circuit is to energize when performing maintenance or repairs. Regularly inspect electrical wiring and equipment for signs of damage or wear. Replace any damaged or worn components promptly to prevent electrical hazards. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Electricity can be dangerous if not handled properly. Consider using a voltage tester to verify that the power is off before working on any electrical circuit. A non-contact voltage tester can detect the presence of voltage without requiring direct contact with the wires. Always follow lockout/tagout procedures when energizing electrical circuits. This involves placing a lock and tag on the circuit breaker or disconnect switch to prevent accidental re-energization. Use appropriate personal protective equipment such as insulated gloves and safety glasses when working with electricity. Insulated gloves can protect you from electric shock, and safety glasses can protect your eyes from arc flash. Be aware of the potential hazards of working with electricity such as electric shock, arc flash, and electrical fires. Take precautions to minimize these risks. If you encounter any unexpected problems or issues while working with electricity, stop immediately and consult with a qualified electrician. Do not attempt to troubleshoot or repair electrical problems unless you are properly trained and qualified. Keep your work area clean and organized. This will help to prevent accidents and make it easier to work safely and efficiently. Store electrical tools and equipment in a safe and secure location. This will prevent them from being damaged or misused. Dispose of electrical waste properly. Do not throw electrical waste in the trash. Recycle electrical waste whenever possible. Follow local regulations for the disposal of hazardous materials. Be aware of the location of underground utilities before digging or excavating. Contact the local utility companies to locate underground utilities before starting any digging project. Avoid working on electrical systems in wet or damp conditions. Water can conduct electricity and increase the risk of electric shock. If you must work in wet or damp conditions, take extra precautions to protect yourself from electric shock. Use ground fault circuit interrupters, often referred to as GFCIs, to protect yourself from electric shock. GFCIs can detect ground faults and quickly de-energize the circuit, preventing serious injury or death. Test GFCIs regularly to ensure that they are working properly. Replace any faulty GFCIs immediately. Be aware of the potential hazards of working with overhead power lines. Maintain a safe distance from overhead power lines to avoid contact. If you must work near overhead power lines, take extra precautions to protect yourself from electric shock. Use insulated tools and equipment. Consider using a spotter to watch for overhead power lines. De-energize the power lines whenever possible. Be aware of the potential hazards of working with batteries. Batteries can contain corrosive chemicals and can explode if mishandled. Wear appropriate personal protective equipment, such as gloves and safety glasses, when working with batteries. Avoid short-circuiting batteries. Dispose of batteries properly. Do not throw batteries in the trash. Recycle batteries whenever possible. Follow local regulations for the disposal of hazardous materials. Be aware of the potential hazards of working with generators. Generators can produce carbon monoxide, which is a deadly gas. Operate generators in a well-ventilated area. Install carbon monoxide detectors in your home or workplace. Do not operate generators indoors. Be aware of the potential hazards of working with solar panels. Solar panels can produce electricity even when the power is off. Cover solar panels with opaque material before working on them. Disconnect solar panels from the electrical system before working on them. Be aware of the potential hazards of working with wind turbines. Wind turbines can be dangerous to work on, especially in high winds. Follow the manufacturer's instructions for safe operation and maintenance. Hire a qualified technician to perform maintenance on wind turbines. Proper electrical safety practices are essential for protecting yourself and others from electrical hazards. By following these guidelines, you can minimize the risk of electric shock, arc flash, and electrical fires.